Hello everyone, my name is Jadran Sessa and today I need to present intelligent automation of crime prediction using data mining. Before diving any deeper into the topic, I will provide a brief overview of today's talk. Proactive crime monitoring is of the essence, especially considering the tragic events that have taken place all around the world and especially in the United States. Hence, I would like to say that research should focus more towards intelligent crime prediction. In our work, we have tried to showcase the potential of data mining techniques in obtaining useful information from the data and gaining understanding of the underlying patterns found in the data. In order to properly understand the topic of crime prediction, crime pattern theory has to be understood, and it can be simply defined as a way of elucidating the reasons why specific types of crime happen at certain areas only and at certain times of the day or days of the week. Criminals usually tend to frequently commit crimes in the areas of their comfort zone, in the areas of their comfort. When it comes to the related work that has been done so far in this particular topic, I have to say that more research is required. But I would like to single out two works that have been done, and those are the works by Tayebi et al., who proposed a random walk-based approach to model FedEx activity space, which they named Crime Tracer. And the other work was performed by Otway et al., who assisted police in the UK in stopping future burglaries by employing neural networks and building a Bayesian belief network for identifying the areas with higher probability of burglary in the future. On top of that, some police departments across the United States have been experimenting with predictive models for identifying individuals who are most likely to commit crimes. For this work, we have used different tools, namely Python, RapidMiner. RapidMiner provides high stability and can run on large data sets without a hitch. It can basically run most of the high-level machine learning and data mining techniques on such data. For data visualization, we have used RStudio. So we have used ggmap, ggplot2, and reader libraries. The first step of our methodology to fetch the necessary data. So in our case, we have obtained it directly from San Francisco Police Department, and they have provided us with the data from the period of June 2003 to May 2015. So the data was on actual crimes committed in the city of San Francisco. The first step after obtaining the data was to pre-process it, which is quite crucial, which is very crucial in any data analysis work, in any kind of data analysis work, and basically defines the quality of classification model. It's consisted of four main parts, namely data cleaning, data integration, data transformation, data reduction. We have also, after doing data preprocessing, we have tested a number of different data mining algorithms, including naive Bayesian algorithm, which is based on the concept of maximum likelihood, which is used independence of the features. We have also used k-nearest neighbors and weighted k-nearest neighbors, which are basically lazy classification algorithms, in which test point is classified into the class of k-nearest neighbors. In the weighted version of this algorithm, weight is calculated as inverse of distance from the test point to the training point. On top of that, we have used more complex models such as neural networks, which are actually a series of algorithms that strive to identify underlying relationships found in our data by creating a process which is reminiscent to the working of the human brain. Neural networks are basically based on the black box approach, since it's difficult to find out what they have learned, and they consist of a number of deeper layers. They can provide high accuracy when working with big data. However, as already mentioned, when working with smaller data sets, they may not always produce the best possible results. On top of that, we have used decision trees, which are hierarchical structures based on if-else statements leading to a decision, in which decision node has two or more branches, and leaf node represents a decision, whereas top of decision corresponds to the best predictor, which is called root node. So decision trees are basically performed in three different steps, including splitting, pruning of or shortening of branches of the tree, and tree selection. Model is usually selected based on the smallest tree that fits the data. After that, we have also tested random forests, which are based on bagging techniques, which exclude the weak features from the model, and in which the samples are created with a subset of features selected randomly for each node in the decision tree. Finally, we have used gradient boosted regression trees, which work by sequentially adding the previous predictors under fitted predictions to the ensemble, that ensuring that previously made errors are corrected. This particular algorithm is based on a number of parameters, including a number of decision trees, maximum depth, learning rate, and so on. It provides advantages of giving good accuracy and generalization, and boosting models which require higher sensitivity of hyperparameters. However, they do not work quite as well with high-dimensional data. Now I'm going to briefly present the obtained results. Gradient boosting algorithm performed the best when working with 2, 3, 4, and 5 different classes. In 2 different classes, it resulted evaluation score was 0.74 for it, whereas for 3 it was 0.52. For 4 and 5 classes, it was just below 0.5. However, when using a large number of classes, namely 39, in this particular example, its performance significantly decreased, and in this particular case, random forest actually performed the best. On the next slide, you can see the types of the crime performed in each different area of San Francisco for both validation and testing data sets. Whereas on this side, on the right side of this slide, you can see that the largest number of crimes was committed on Fridays, whereas the smallest number of crimes was committed on Sundays. You can also see that larceny and theft was the most commonly committed type of the crime, accounting for a total of 20% of all committed crimes in the data that we have analyzed. On top of that, crimes such as assault, drug, narcotic-related crimes, and vehicle theft were also quite common, as well as other offenses. Figure on the left shows a heat map of different crime types, and the darker color is, the more crimes were committed in that certain area of San Francisco. Here we can see the total frequency of different crime types for both training and testing datasets. Whereas on this slide, we can see line charts which showcase the total number of criminal occurrences across different days of the week for both training and testing datasets. And it can be seen once again that larceny and theft was the most commonly committed type of the crime, followed by the other offenses and assault. To wrap it up, I'd like to say that the use of machine learning and data mining techniques can be utilized to develop online monitoring systems for crime prediction, and thus revolutionizing the way the proactive law enforcement occurs. The training of the crimes data has been done to perform model selection in our particular case, and as I have already mentioned before, gradient boosting decision trees proved to provide the best evaluation scores when working with 2, 3, 4, 5 different classes, whereas its performance significantly dropped while working with higher dimensional data, namely with 30 or more different classes. Its performance was not as great in this case. In that case, random forest performed actually the best. In our work, we have also utilized geographical data to enhance performance of classification. In the future work, we should put more focus on the impact of feature selection, as well as on studying effects of feature selection, successive performance, and performing prediction using even more classifiers than we did now. So